We have previously done all kinds of graphing. We've graphed all of our parent graphs. The last parent graph we graphed was an exponential graph. This graph right here that's on red on my paper is the exponential graph. And when we started learning about logarithms, we learned that it was the inverse of an exponential graph. How do you get an inverse? Do you remember about inverses? What do you do to get inverses? Switch the x and the y. And so that is how we came up with this log graph. This is log base 2 graph. And the exponential graph had a asymptote here. When you switch the x and the y, the log graph has an asymptote here. Do we remember what asymptote means? Gets closer and closer and closer to the asymptote without ever touching the asymptote. When you change the x and the y, what happens to the domain and range? They switch. Now, I have a little bit of a problem calling this point right here a vertex. I call that point right there a key point. It's a very important point to our graph. It's the x-intercept of our graph. But I learned in geometry that a vertex is where two sides come together at a point, and that doesn't really seem to apply to this point right here. So instead of calling it a vertex, I call this point right here a key point. Now, once you know what the parent graph looks like, then we use our same old rules. What is the x minus 5 going to do to a parent graph? If the x minus 5 is in parentheses with the x, is it going to move it up, down, left, or right? It is going to move it to the right. If we have a plus 2 out on the end, what's that going to do? That's going to move it up. If we have a negative sign in the beginning, what is a negative sign going to do? Reflect over x or y? And so all of those same rules apply. They're still the graphing rules, and so if we know what the parent graph is, then we can make the transformations. Now, the hardest thing to figure out on your graph is the base. And here is how you figure out the base. You count from the asymptote 1, 2, 3, 4. And we're going to go through and do all of the bases. We're not going to spend a lot of time on that because on your homework paper you are going to be given the bases. So the base on problem number 1 is 4. The base on example 2 is 1, 2, 3. That's right there is where you count the base. The base on example 3 is 7. This point right here is where you count the base. 1, 2, 3, 4, 5, 6, 7. Example 4 has a base of 10. Here's where you count the base of 10. Okay, now we're going to go back and fill in the rest of it on example number 1. On the exponential graph, the first thing I figured out was the asymptote. On this graph, the first thing I'm going to figure out is the asymptote. They made it easy. They put in a dotted line for you. Where is the asymptote? This is not correct. That tells me the asymptote is this point right here. Is the asymptote a point? No, it is a line. It is the line that crosses the x-axis at -7. The asymptote is x equals -7. And the asymptote is going to help us figure, the asymptote's going to help us figure out the domain and the h. If that's the asymptote, the range is from here up, -7 to positive infinity, and the range is going to be the same on all of them. The parent graph had an asymptote at the axis. This one has an asymptote at -7, so it moved to -7. The parent graph had a key point on the axis. This key point is 1, 2, 3, 4, 5. Now that I have all of the pieces, I just plug them in to an equation. Log base 4 of x plus 7 plus 5. But I thought it was -7. Why is it plus 7? X still changes signs just like it has been doing since August and beyond. The first thing I'm going to figure out is the asymptote. The asymptote's going to help us figure out the domain and the h. Where is the asymptote? That means the domain goes from 2 and gets bigger. The domain goes from here up. And the parent graph has an asymptote at 0, so this has been moved right too. This is the key point, 1, 2, 3, 4, in the negative direction. The key point has been moved down 4. Log base 3 of x minus 2 minus 4. This changes signs, this does not. First thing I'm going to figure out is the asymptote. That's going to help me with the domain and the h. Where is the asymptote? So the range goes from -10 up, and the graph has been moved -10. This is the key point. The parent graph has the key point at 0, so this has gone down 2. Put it all in to the equation. By the way, this is g of x. G of x usually indicates a transformation has happened. We have one last example. I always do the asymptote first, and that helps me get the domain and the h. The asymptote is at x equals -6. The h is at -6. The domain is -6 to infinity. The key point is 1, 2, 3, 4 in the negative direction. The key point is right here. The equation is log base 10. But when the base is 10, I don't have to write the base. X plus 6 minus 4. Now, since this is base 10, you can actually put this in your calculator and check it, but it looks a little bit different on your calculator. On your calculator, it looks like it stops right there, but does it? That would be right here on this graph. Does it stop right there? Why does it stop on the calculator then? The points are getting so close together that the screen cannot display them because this is not a high definition screen. And so that's why you have to know what the graph looks like to begin with, because sometimes the calculator can trick you if you don't know what it is you're supposed to be looking for. I would like to go back over here to the parent graph. When you look at the parent graph, this is the parent graph, and right here again is the asymptote. Does this help you understand why the log of a negative number is what? Why is it like that? Do I have any x values over here? Is my graph over here anywhere?